Good afternoon, everyone. So, dear authors and invited guests, welcome to the technical session 5D. I am Meghna Mathur, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Kamlesh Ahuja. Welcome, ma'am. She is an associate professor and the head of the Artificial Intelligence and Data Science Department at Mahakal Institute of Technology, Ujjain, India. With over 9 years of academic experience, she is a dedicated educator and researcher in computer science, information technology, and AI and data science. Her teaching portfolio includes core subjects such as machine learning, artificial intelligence, cloud computing, and deep learning. Welcome, ma'am.
Thank you. Thank you, ma'am.
Ma'am, now I would like to start with the papers.
Yes, please start.
Our first paper is being presented by author Arya Keskar. The title of the paper is A Hybrid Federated Learning Architecture with Teacher-Student Framework for Privacy Preserving AI.
I think he's not in meeting. So moving ahead to call our next presenter.
Our next presenter is Kothai Ji. The title of the paper is A Stacking-Based Machine Learning Approach for Cardiovascular Disease Prediction.
Good afternoon, ma'am.
Good afternoon.
Good afternoon.
Ma'am, I am Darshana Kumar, co-author of the paper. Instead of Goday, ma'am, I'm here to present the paper.
Yes, sir. Please start your presentation.
Yes, ma'am. Thank you. Ma'am, is the screen visible?
Yes, it's visible now.
Good afternoon. My name is Darshana Kumar, and I'm here presenting on behalf of my research team. Today, I want to share with you work that could genuinely impact how we detect cardiovascular early detection using ML models. Uh, why heart disease prediction matters? Here today, the heart, we are addressing heart disease is one of the most cause of creating death. Uh, the traditional models are used to detect the heart disease which are not having the complex or linear patterns in it. To overcome these limitations in the traditional model, we approached a advanced technique by combining more two or three ML models together and using their outputs as input to another model. This is our here, what's our solution? We proposed a stacking ensemble learning approach. This is not a single algorithm. Instead, using a single algorithm, we combined two or three techniques which uses various methods to identify patterns among the given data and combine those outputs. We are going to uh, predict the output. Here are the traditional models which already is in the use. In the approach one, they used two-level stacking systems. In that, the base learners are limited, like a single base learner, and there is no boosting, so that it cannot find any complex relationship. It can identify only the simple relationship. In the second approach, they used extra trees like random forest and XGBoost. In this, they used any complex algorithm. Only tree-based algorithms were used. In third approach, using principal component analysis, the feature is extracted and SVM is used for backing the data. That the only special feature included is that SVM. Here the uh, heterogeneous various laners are been used to find the complex relationship. By using the in fourth approach, they use the transformer feature extraction and classification. It gives nearly a 97 percentage of accuracy, but it is not enough to predict the heart disease because it is a sensitive one. So we need more complex algorithm to predict it. In our algorithm, it achieves 98.05 percentage of accuracy. This is the proposed methodology which we used to find the best solution. In base model, we actually use a stacking classifier which combines more models like a base level which uses base ML models and meta model which combines the outputs of the base models. The meta model gives the output which is captured by the stacking classifier and produces the final output. In base model, we used decision tree classifier, ADA boost classifier, and gradient boost classifiers. Each of them are different algorithms which is used to find the patterns among the data and produce different outputs or various outputs from the input data. These outputs are fed into the logistic regression as input. The logistic regression find the patterns from the input given as the output of the base models, and the stacking classifier produces the final output by integrating these base model and the meta model. And this is the basic workflow which we used. We used a dataset, publicly available dataset, which is downloaded from the Kaggle. First, we pre-processed the data according to the need of the algorithm. and we splitted the data for training and testing. We used 80% of data for training and 20% for testing, and we fed that data into the base model. After the base model's output, the output is fed into the meta model as input. From the meta model, the stacking classifier integrated these algorithms and produced the final output. And we used the basic process in the data pre-processing. In this, there is no missing values, and it has 499 no predictions, and 526 it's predicted positive, so it is balanced data. There is no possibility for misbalance in the data set. It's a perfect data for training. And numerical features like mean value is 0 and variance is 1 for which is used for the model's optimal performance. In the categorical feature, we for genders and blood groups, we used one hot encoding which converts that characters into numeric, like for male 1 and female 0. Likewise, it's encoded the values, and we removed the unwanted columns. And first of all, we need to explore the data to find which type of method we need to handle, and what is that we are going to use. In this, from the analytics, we can see that the green line is showing that no heart disease, and the red bar is showing that it's predicted as heart disease. We classified among the gender, and here we are separated using age categories from 30 to 40 and 40 to 50 and 50 to 56 and 60 to 60. From seeing this, we can understand the data. From seeing this, we can understand the data, how the data are spread, and which how the data is loaded, which is suitable for training or not. This is the system architecture. First, we split it. First, after the data pre-processing, we split the data into two categories. One is for training, and one is for testing. The training set is fed into the base model, for decision tree, ADA boost, and gradient boost. Their outputs are combined and fed into the meta model as a stacking classifier. From that model, it's predicted the output, and we used the basic performance matrices like accuracy, ROC, and AUC, recall, F1 score. By using these matrices, we concluded the accuracy and output of the model. We used
Sorry
cross
to interrupt,
validation. Yes,
Darshana.
ma'am.
This is a gentle reminder. You have 1 to 2 minutes to conclude your presentation.
Yes, ma'am. And we used cross validation to check how well the data is working from the unseen data. For using cross validation, we used a tenfold, which splits the data into 10 parts. One part is for testing, and the remaining 9 parts are using for training the model. Likewise, the 10 parts also used for testing, and each on the except that one part, another remaining 9 parts are used for training the data. Result and conclusion. Here, by using the confusion matrix, we can see that the model correctly predicted that is no heart disease as 92, and the correctly predicted the heart disease is actual heart disease 103. It misclassified that, but there is no heart disease, but it predicted as heart disease as 2 cases, and it has heart disease, but it predicted not as in 2 cases. Thank you.
So it was nice presentation.
Thank you, ma'am.
You are getting 98% accuracy, right? So
Yes,
which
ma'am.
data set you are using, like some existing data set, or you are using some practical attributes you have collected?
Ma'am, I used an existing dataset which was known as
And which one?
UCI. Ma'am, UCI machine learning repository from Kaggle IT.
Okay, okay. And for meta model, you are using logistic regression.
Yes,
So
ma'am.
have you faced any overfitting issue in your meta model?
No, ma'am, I didn't face anything.
Okay. Thank you.
Thank you.
Thank you.
Yes, ma'am.
We'll move further with the next presentation.
Hello, hello, hello. లోపల ఉండు, ఒక్క నిమిషం.
Just give me a minute. So our next paper is presented by Arya Keskar. The title of the paper is A Hybrid Federated Learning Architecture with Teacher-Student Framework for Privacy Preserving AI.
Can I start sharing my screen?
Yes, please.
Are you able to see my screen? And I'm audible, right?
Yes.
So yeah, good morning to the panel and fellow authors. Today I'm here to present our work titled A Hybrid Federated Learning Platform for Private and Self-Improving AI. This work proposes a hybrid learning architecture that balances high model performance with data privacy, particularly for enterprise and regulated environments. This is a general roadmap for my presentation. So I'd like to start with introduction. Large language models have achieved strong performance in tasks such as code generation and text summarization. However, these models are typically centralized, requiring user data to be sent to an external server. While centralized AI systems are highly accurate, they are fundamentally not private and unsuitable for enterprise use case involving proprietary or sensitive data. On the other hand, fully local LLMs preserve privacy but are computationally expensive, difficult to deploy at scale, and generally less accurate than centralized models. Basically, there is a fundamental trade-off between privacy and performance. So this is where our research objective was. The objective was to design a hybrid federated learning architecture that combines the performance of centralized AI and also guarantees privacy of decentralized learning. So to formulate the problem, as discussed earlier, centralized learning provides strong performance but violates data sovereignty and regulatory constraints. Federated learning preserves privacy by keeping the data local, but it suffers from certain limitations, including the cold start problem, non-ID client, slow convergence on complex generative tasks. So this is the literature review. Like the federated learning was introduced in 2017 by Google. There also, after the introduction of federated learning, several problems arise, such as cold start problem. So in federated learning, there are various desktops, and these desktops send the feedback towards global AI. So at the start of the at start, the global AI doesn't have any enough context, so it generally gives wrong answer initially. But as as like as long as the different desktop give feedback to the global AI, it overall what do I say? It improves the global AI. So so our main objective was to gather all these different features into one hybrid architecture. So this is the basic proposed architecture. I would like so yeah, the system operates as follows. The user interacts with the local student AI separately on a local machine. The local student AI learns using LoRa on private data. LoRa stands for low rank adaptations. Basically, uh, rather than training the whole model, we just train the parameters which are relevant to the task on that personal laptop or a PC. Yeah. So the local student AI learns using LoRa on private data. Only LoRa weight updates are produced. Updates are encrypted and sent to the federated learning server. This FL server securely aggregates updates. The aggregated updates improve the global student AI. The teacher AI periodically analyzes the global student AI, and then the teacher AI also generates the synthetic data which are fed to the global AI. So there are two ways we can do here. One is the teacher AI can uh, like periodically check on the global AI, or the global AI can send the feedback to the teacher AI whenever required. So let's say the global AI sends the feedback to the teacher AI that it has to be improved. Then the teacher AI sends back the synthetic data upon which the global student AI can train. This creates a continuous privacy preserving learning loop. So basically, this architecture can be implemented to any domain, like code generation or text summarization. But for the proof of concept, I coded a pro I, I coded a program which is used to generate Python programs. So let's say I have to generate a code for palindrome check. So initially the local AI generates a palindrome code. So as you can see, there are several comments to the comments to the code. And if as a user I don't want comments, so I'll get rid of the comment uh and say that the code should be concise. So the system learns from the feedback given by the users, and as you can see, the current preference says prefer less comments. So the next time, if any user asks for any other code, they would be provided with the code with less comments. And basically, the feedback that is sent from the user to the FL server, it has to go. It is encrypted, meaning that the feedback has some added noise so that the any third party or any attacker would not know what was the feedback given by the user to the FL server. And when the FL server improves the local AI and still the user is not fully satisfied by the answer, then the global AI can ask the help from the teacher AI, which is a centralized external AI. Uh, the external teacher AI then sends back the synthetic data to the global AI, upon which the global AI can, learn from it and improve the accuracy of the model. This is the entire loop. Uh, so now I've also evaluated the whole architecture thing. So basically there is a centralized oracle such as ChatGPT or Gemini. Then there is standard FL server which only improves from the feedback from the local machine. And then there is our architecture, that is hybrid FL architecture. As you can see, initially the FL server or the global AI doesn't have enough context, so it starts with very less accuracy, like 4.03%, 4.30%. But in hybrid FL architecture, the global AI or the FL servers has the context from the teacher AI also, which drastically improves the accuracy in the initial step, like 38.20%, which solves the cold start problem. So to mention about the percentages and the benchmark, I have used a data set called a human eval, which was generated by ChatGPT or OpenAI to, check on the models and like how they work. So in human eval, there are 169 handwritten Python code, and there I have also used an evaluation matrix known as pass@1. Means that like if there is a Python code and it has certain output, then in first try, what is the like what amount of code out of 169 gave the correct answer. So in this case, out of 168 Python programs, the central oracle gave about 94.5% of questions correctly, and in standard FL server, it gave us 4.30, and in hybrid FL architecture, 38.20%. And I would like to also note that key the centralized oracle is the pinnacle of the architecture. But if you want high privacy, but you are able to, let go some accuracy, so we can use this hybrid architecture. This is the same result on the graph, and yeah, these are the references. Thank you. I'm
Yes,
open
you
to questions.
presented very well.
Yeah,
My question is, in your previous slides, you discussed
yeah.
there is a lacking in data governance principles. So, in your work, how will you manage the data governance principles?
Can you please elaborate, like what do you mean by data governance?
You discussed like in your existing work, in your literature review, there is lacking like data governance principle. They will not manage the data governance principles. So, my question is, how you will manage the principles in your work?
So, like how the data goes from a user to an
Yes,
FL server,
yes,
or
yes.
yeah. So basically, the data doesn't leave your local machine. The data is with the user only, but
Okay.
there are certain weights assigned to the data. Like if if there is a Python code generation, the
Hmm.
accuracy of that Python code or the syntax or like mentioning uh any variables, there are different parameters to the Python code. So the weights are assigned to these parameters. So if I say there is a Python code which lacks any logic, says it declares unreasonable amount of variables. So the variable parameter would be given highest weight, and these weights are sent to the global layer. And this
Okay.
feedback is sent to the global layer, and the global layer improves the local layer.
Okay. And how you are giving the training to advanced teacher brain in your proposed model? There is advanced teacher brain.
Advanced feature training.
Yes.
Um, Sorry,
In your
I'm not
proposed
able.
model. Yes.
Feature training. Like I don't know what that term means. Feature training.
Okay. Okay. Just check your proposed model and you got to know. Okay. Thank
Yeah,
you.
sorry. Yeah.
Thank you. We'll now move further. Our next presenter is Bhargav Modi, and the title of the paper is Air Quality Forecasting in Indian Smart Cities Using Artificial Intelligence and Supervised Ensemble Learning Models.
Okay. Good afternoon, ma'am.
Yes, good afternoon, sir.
I can't share this my PPT. Okay. Yes, ma'am. Yes. Is it visible, ma'am?
Yes, sir, it is.
Okay. Shall I start?
Please start.
Okay. Good afternoon, ma'am. I am Bhargav Modi, research scholar. Today, I am honored to present my research entitled Air Quality Forecasting in Indian Smart Cities using Artificial Intelligence Supervised Ensemble Learning Models. This work focused on improving the air quality predictions accuracy using the advanced machine learning technique use. This presentation is organized as follows. I will begin with the introductions, literature review, research problem, objectives, data source, model architecture, results, comparisons, conclusions, future works, and references. Now, I'm moving the introductions. In the today's era, the hot concern is air pollution in the most of the countries. Air pollution is considered to be one of the most dangerous and common type of the environment pollutions that has been reported in the most industrial towns and the India. In India, such as Ahmedabad, Delhi, Amaravati, Kolkata, Coimbatore, Chennai. The air pollution has become a critical issue in the Indian cities due to the rapid industrial growth, urbanization, traffic, and energy consumptions. Poor air quality affects the public health and impact the environmental sustainability. Smart cities today use the IoT sensors and the monitoring systems to continuously track pollutants like PM2.5, PM10, NO2, CO, and O3. However, the predicting air quality accurately is still a major challenge because the pollution levels change rapidly with the weather, the conditions, and seasonal patterns. Now, I will move the literature review. In the recent years, the several researchers have worked on the forecasting air pollution using the machine learning approaches. For example, Kumar et al. You published the paper 2021 used the random forest in the Delhi and achieved the better predictions accuracy compared to traditional models. Patel and Mehta published 2022 implemented gradient boosting for the PM 2.5 predictions and the reported R-square accuracy of the more than 90%. Singh and Sharma published 2023 highlighted that the single machine learning models often fail to capture complex environmental behavior and ensemble method generally perform the better. These findings motivated us to explore the supervised ensemble learning approaches for more accurate AQI forecasting in Indian smart cities. However, we found that very limited research compares multiple ensemble models, specifically for Indian smart cities using the multi-year environmental data. Therefore, our study focused on evaluating the random forest, gradient boosting, and XGBoost for the more accurate AQI forecasting. This is a literature review in here, like present in here, like the graphical representation. Now all are the same. Next is research problem and gap. Many systems exist for measuring the air pollution levels, accurately predicting future AQI values remain the major challenges. Traditional statistical models struggle because air quality data is highly irregular, nonlinear, and influenced by the many dynamic environmental factors such as weather, traffic, temperature, humanities, and seasonal behaviors. So, past studies we have used the single model, use the single model such as linear regressions, SVM, and neural networks, but these models fails to capture complex patterns. Therefore, there is a need for more robust and capture predictions model and assemble machine learning technique used for the better performance by the combining multiple algorithms. Then now I move the objectives. The objective of our research are focused on improving the accuracy and reliability of air quality index predictions in Indian smart cities. First, we aim to develop and implement an ensemble machine learning based model for forecasting AQI using multi-year environmental data. Second, we compare the performance of ensemble models such as random forest, gradient boosting, and XGBoost with the traditional model, including support vector regressions and linear regressions. Third, we identify the key environmental and pollutants factors that significantly influence AQI levels such as PM 2.5, NO2, and temperature. These objectives will help enhance the smart cities air quality monitoring and allow early preventive actions. So now we are moving the data source. I have used the data stores using the data store include the daily measurement of the several key air pollutants such as PM 2.5, PM10, NO, NO2, SO2, CO3,
Hello?
along with the meteorological and chemical indicators.
Hello?
Hello. This is a correlation matrix in here data source. So now this is my consists of four components: data acquisitions, reprocessing model, development, and evolution metrics. We collected multi-year air quality and meteorological data from CPCB, Central Pollution Control Board, and OpenEQ and Kaggle.com. For the major smart cities using this data set includes the pollutants indicators like PM 2.5, PM10, NO2, SO2, CO3, and weather features like temperature, humidities, and wind speed. The processing and missing values were handled using the KNN and medium inclusions. Outliners were managed using the Z-score analysis, and min-max normalization was used for scaling. The data set was divided into 75% for training and 25% for testing. We implemented three supervised ensemble models: random forest, gradient boosting, and XGBoost, and compared them against the conventional models such as linear regressions, decision tree, and support vector regression. Model performance was evaluated
Hello,
using
madam. Meghana Mathur, madam.
MAE, RM, SE, and R square matrix. So now this is my model architecture. Now we are moving on result part. So random classifier as using models results in his PPT. The fit the random forest classifier on the training data set. Predict the X underscore test means predictions, labels, X underscore train, and X underscore test is input data like PM 2.5, NO, and SO2, etc. Y underscore train and Y underscore test data labels for the AQI categories. After the training, we evaluate the models on the test asset and analyze its performance using a confusion metric. Confusion metric shows the model classification on different AQI categories. This is a confusion matrix in here. So this is a column is represented predicted class and row is represented actual class. Like insights from the matrix, correction prediction diagonal is 381, 36, 15, 825, 2292. 348, 692 is a correct predictions. Rest of others are misclassification of kernel. This is my result part. So this is a comparison in here. Now these comparisons clearly shows that the assembled models outperform traditional models. Along all the models tested, random forest deliver the best overall performance. Gradient boosting and XGBoost are also well, but the random forest shows the superior stabilities. Like support vector is accurate 81% accurate, decision tree is 85, gradient boosting is 87, XGBoost is 89% accuracy, random forest is 92% accuracy. So this why you are using the random forest, the like algorithm in here. So conclude this my PPT, like to conclude this study demonstrate that supervised SML machine learning models provide the significantly higher accuracy for air quality index predictions compared to traditional statistical techniques. Among all the models tested, random forest deliver the best performance with the lowest error rate and highest prediction stability. The future, the importance analysis really revealed that temperature PM 2.5 NO2 are the most critical factor influencing AQI levels. The proposed framework can support smart cities systems to monitor air quality in the real time issue, like early warning and the guide policy planning towards a healthier environmental. So now I move to future work. Although the result of our
Sorry to interrupt, sir. You have 1 to 2 minutes left for the conclusion of your presentation.
Okay. Although the results of our research are very promising, there are the several opportunities. So future enhance in future work, we plan to integrate real-time IoT sensors data to enable dynamic and live AQI forecasting. We also aim to scale the model to a national level deployment, the covering more cities and rural regions. Another direction is to explore the hybrid architecture that combine the ensemble learning with the deep learning models such as LSTM or CNN for future accuracy improvement. Additionally, developing interactive dashboards and the mobile application will help the citizens and the authorities access external environmental data in the user-friendly formats. So this is my future work. So this is the references which I will use in the here, and thank you.
Yes, good piece of work, sir. Actually, sir, you took data set from 2015 and took from Kaggle, right?
Yes,
And
ma'am.
particularly you worked on Delhi AQI, right?
Yes, ma'am. Because of
But
this
yes,
is a sample data, everything is not
yes,
in mentioned in here, so that's why I am putting the only for the Delhi.
yes.
That's
But
all.
sir, in current scenario, we see there is AQI crossed 400, right?
Many. Yes, ma'am. I also read the like yesterday's paper AQI is 500. Sorry.
Five, yes. Now,
That is a big
yes.
a big value, like and that is a very crucial part, like in the Delhi part. That's why.
Right. So according to your work, because you are working, you are researching on that. So what measures we should take for particularly Delhi region by your work?
Measurement in the sense like input values. I think so.
No. What measures you should like we should take to improve the AQI in Delhi particularly?
Okay. Now the like this is a government policy, so they are decided to which types of actions will be taken on that part. But I just give the AQI level. So like this is a high or that is like good, better, severe, like that.
Yes. So can we contribute from our work?
Yes, in future I will definitely contribute some like with IoT like sensor then implement and combine that work like like practical like IoT just get the data from the like AQI and cloud based. Just I will just future work on.
Okay. Okay, sir. All the best. Thank you.
Thank you, ma'am. Thank you for the giving the opportunity.
Thank you,
Shall
sir.
I,
We'll move
shall I
forward
remove?
now.
Shall I remove?
We have our next presenter, Moina Ajmeri. The title of the paper is Optimal Fractional Order Model and Smith Predictor Control for Higher Order Systems.
Good afternoon, ma'am.
Good
Good
afternoon, please
afternoon.
share.
Good afternoon, ma'am. Am I audible?
Yes, ma'am, you are.
Okay. Uh, Hello, everyone. I'm Dr. Moina Ajmeri, working as an assistant professor at NIT Patna in the electrical engineering department. Today, I'm very happy that I'm going to present on the topic. Thank you for giving me chance, ma'am. The topic is optimal fractional order model and Smith predictor control for higher order system. First, I would like to give quickly what is the need actually. In this work, two minor works are reported. There are two sub parts of the work. First, the higher order system means the transfer function is having the denominator with the order 5, 6, 10. So, first we need to reduce the order of the system by using some techniques. So, here we are obtaining the lower order fractional with emphasis on the fractional terms. First, we will obtain the lower order model equivalent to the given higher order model, and then based on that lower order model, we will be designing the Smith predictor control. And Smith predictor control is a specific type of control which is particularly suited for the processes having large time delay. So let us see what are the what are the things here. First, I would like to mention the objective. As I have told, there are two main objectives. First, to obtain the lower order system equivalent to the given higher order system, and then to design a Smith predictor control. And the introduction of those brief explanation of those terms will be given, and then design part will be presented, and then conclusion, and then references. So, as part of the research, first we should focus the literature review, and from the review, we can see the different work, and then what is actually the control system application. My area of research is control system design. So it is widely used in real-time applications. We can see Segway, rocket, aeroplane, various process control, medical lines, everywhere control system is involved, but control system totally depend on the process whose output is to be controlled. So there are two ways that first the control method may depend on the model of the system, or it may take the actual system to control its output. So here the control is based on the reduced order model. So to simplify the dynamics of the system or understanding of the system, we obtain the reduced order model that will also reduce the computational complexity, and obviously it will reduce the computation time. And when we realize the reduced order model, that will require less hardware. Now, first, let us see how the model reduction is done. Here we can see the original system, which is of high order, and the reduced order model. If we give the step input here, then if the reduced model is very close to the original model, then the same output should be obtained from the original system as well as reduced system. So we are taking the advantage of that error, and we are optimizing the error. We are actually minimizing the error using Jaya optimization technique. So for reference, we have taken the high order system as A1 s to the power n minus 1 plus A2 s to the power n minus 2 divided dot 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 divided by, similarly we have another polynomial in the denominator. And the reduced order model is considered as containing only two unknown terms in the denominator, and then the powers of s are mu1 and mu2. As it is fractional order, so mu1 and mu2 may take any real value. Here we have assumed that mu2 should lie from 1 to 3 and mu1 should be less than mu2. So the motive here is to obtain the unknowns Km, A, B, mu1, mu2 using J optimization method. And here the objective function is taken as this error, square of this error, ET. So here we can see the flow chart of the Jia algorithm. I will not go into the detail of that, as we have not developed this. We are just using this method. Someone has proposed this. In brief, I can say, okay, here the how it works. It tries to eliminate the unwanted solution and the best solution it takes. So, and ultimately at the end, we'll get the unknown parameter corresponding to the minimum value of that error, that objective function. So after obtaining the reduced order model, we have focused on the Smith predictor design, which is actually a dead time compensation technique. So what is the time delay? Here we can see if we are taking y upon r equal to this equation, e to the power minus theta rs, this e to the power, this theta is actually the delay. So whenever the system contains the delay, the control will be difficult, as the process time delay may cause reduction in the phase margin or the gain margin as well. So that will disturb the stability of the system. That means controlling this process may be a challenging task to the engineer. So Smith predictor will take care of that process time delay, and it will give the smooth set point tracking response. It actually removes the effect of internal delays, as that that advantage will be visible from this equation. Here we can see this is the schematic of Smith predictor. Here we have a process GP and its reduced model GR that we have obtained already using G optimization method. And then this delay part we have taken separately, and this difference of the model and the y, this difference is fed back here, and the comparison is done with rs. And so this is the transfer function y upon r. So when we assume that gp equal to gr, then we'll get this simplified y by r, where we can see the denominator is totally free from process time delay. So that is the work of Smith predictor. So based on this equation, we can proceed for the design that as we have as we are using direct synthesis method for designing the controller. So this is the formula for that method, GC equal to this. And this y by r desired is taken as with the help of references, we have found that we can take the desired transfer function as this. So after substituting this y by r desired to GC, we'll get this equation. And then rearranging above, we can have a standard fractional order PID control GC. And just designing the controller is not meaningful if we don't check the validity. So here I have taken two examples. First is higher order system, whose order is 10. So we have obtained the reduced order model using, so what we have done, we have also used PSO in our some other work. But here we have presented that how the PSO and JA is working. And this previous articles we have taken Lafia and Wang et al. And similarly, the controllers that we have proposed the formula here, the controller parameters are also included. Now, this table compares the performance. We can see that the proposed reduced order model is giving small ISE 0.001716 with Jaya optimization method. This is the model order reduction performance. Next table tells us the control performance, means how the closed loop output is behaving. So settling time, percentage overshoot, and IAE are calculated in this table. And the graphical comparison, we can see the reduced order model. So
Sorry
I
to
did
interrupt,
the
ma'am. This is a gentle reminder that you have 1 to 2 minutes left for the conclusion of your presentation.
Okay, ma'am. Thank you. Here the comparison between the actual system and model, we have included similar analysis we have done for this load frequency control system, and this is the performance analysis, and this table tells the comparison, and then here we can conclude the work. Two motives are achieved, and references. Thank you, ma'am.
Yes, ma'am. Very well presented, ma'am. So, ma'am, for the time delay purpose, you are using Smith prediction predictor control or something else?
Uh, for time
For
delay,
time delay, yes.
Smith predictor is for control, ma'am, and
Control, okay.
uh, and model order reduction is done using that J
Okay. And what's
optimization
the
technique.
difference between PSOs and JR?
These are two different meta heuristic optimization methods, ma'am.
Okay.
Those two methods are reported by different authors. And
Okay, okay.
PSO was older, and J optimization is new one. And but whenever new optimization method comes, we take the PSO as a reference, particle swarm optimization.
Mhm.
Its full form is, and if it is comparable to that PSO, we can say our method is okay. That is actually reference in this field, ma'am.
Okay, ma'am. Thank you.
Okay, thank you.
Thank you, ma'am.
Okay. Ma'am, shall I stop here?
Yeah. We'll now move further. Our next presenter is Shiva Teja Ragula, and the paper title is Political Security Threat Prediction Framework Using Hybrid Lexicon Based Approach and Machine Learning Technique.
Yes, madam. Shivateja, I'm Shivateja, madam. Hello, can I share it, madam? Is it visible, madam? Hello.
Yes, sir, it is visible.
Okay, madam. I am Shivateja, working as assistant professor in IRE College. Today, I am here to present this PPT, Political Security Threat Prediction Framework using hybrid lexicon-based approach and machine learning technique, madam. So first of all, we'll discuss what is abstract. Abstract is nothing but political security is a critical component, having growing threats often in the form of political unrest or terrorism, or like a framework leverages like a hybrid lexicon-based approach or machine learning techniques, provide some accurate threat assessments. So here the hybrid lexicon-based approach utilizes a critical dictionary of political sensitive terms, madam, to capture the intensive and nature of online. So let's go for the introduction. Introduction is nothing but political security threats having ranging the civil unrest and terrorism to cyber attacks, and disinformation campaigns can establish government disparate societies pose significant risk, madam. Recent advances in artificial intelligence and natural language processes and machine learning, they have paid for developing predictive models and having volume of data in real time, madam. So while several ML techniques have been applied in threat detection or lack lack of interpretability, and fail to account in the nuanced language. So, on the other hand, lexicon-based approaches which realize the predicted dictionaries, political sense or terms, and having that threat detection, but having struggled with the adaptability. Coming to the literature survey, predictive civil unrest through social media analysis. Authors are John C. Stevens and Meredith Clark. So this study explores how the social media can be used in predictive civil unrest by combining sentiment analysis with machine learning techniques. So the author developed a lexicon emotionally charged terms frequently used in during periods of unrest and apply sentiment analysis and framework to a social media data. So coming to title, a machine learning approach for identifying a political crisis using new data like Simon R. Haggis and Angela Patel. So Haggis and Patel investigate the role of machine learning in predictive political crisis by analyzing news articles, and their approach relies on supervised learning models including support vector machines and random forest trained dataset and historical crisis. So first of all, we'll discuss about existing systems. So several systems have been developed to predict political security threats. So combining of lexicon approaches and combining of lexical approaches and these systems are enhance the accuracy and timeless threat detection. So this system utilizes the predefined dictionary and political sensitive terms to identify the segments. So the upload lexicon is then used to conjunction the matching algorithms and categories that having transformers as employed to detect complex patterns and relationship data. So existing system disadvantages are nothing but static lexical limitation, computational resource intensity, scalability issues, interpretability changes, dynamic lexical management system. So here it is the uh, proposed system. Here the proposed system of political party having some threat predictions. So they having the limitation of existing models by integrating dynamic lexicon based approach with advanced machine learning techniques, madam. At the core of the proposed system is a dynamic lexicon that evolves in response to emerging political discourse. So the system leverages as a suite of machine learning algorithm like predict political threats. So the proposed system includes a feedback of loop that enables continued improvement and a new data is collected or analyzed. The system learns from its prediction and model lexicon accordingly. So proposed system is advantage is nothing but enhanced adaptability, improved predictive accuracy and scalability and flexibility, enhanced interpretability and continuous improvement of through feedback. So system analysis is nothing but the process framework integrates that dynamic lexicon-based approach with advanced machine learning. And data processing is a crucial aspect, and the framework begins collecting the pre-processing data, diverse including social media platforms and news feeds. So the system employs a combination of machine learning models to analyze the pre-processed data. So a key feature of the proposed system is dynamic lexicon management techniques. And this is the system requirements. System Pentium 4 2.4 GHz, hard disk 40 GB, RAM 512 MB. Software coming to the software requirements are nothing but coding languages in Python. Operating system is Windows. This is the system architecture, madam, where we know, and these are the screenshots of the political threat program. This is the code, madam, and this is the graph where political system prediction having, and this is also code, madam. And conclusion, the conclusion proposed framework is a predicting political party threats which combines a hybrid lexicon based approach. So that can be method of analyzing, anticipating political risk, and the synergy between these methods ensures that system remains relevant and system remains response evolving political context in emerging threats. Overall, the framework represents a significant advancement field political threat in hybrid nation, for offering valuable insights and policymakers of signature agents. And coming to the future work, in future work, there are several avenues can be explored in the enhanced political security that utilize the hybrid lexicon-based system across machine learning, integrating the multi-modal data sources such as social media, news articles, historical threat roads could provide a more comprehensive understanding political threats. Future work should include some developing robust machines like transparency, accountability, and migration, build trust, ensuring fair application of priority system. So these are the references by DG AY Jordan Chengji, Bristons, MS 2015, Tang B and Li 2008, Scotty C 2017, Smith LR and Xiang M 2019. That's it, madam.
Okay. You presented very well, sir.
Okay.
I have a question. How, in your model, how language, region, and cultural content, or we can say context, influence the effectiveness of the political threat?
Sorry, madam. Your question is I
Like
didn't
how
understand your
language,
question.
region, and cultural context influence the effectiveness of your political threat?
There are nothing but who want to delete the data, means who want the data of some of the political parties threats, so they will threat them. So we have to hack the who want to the threat to the political parties, madam.
Okay, thank you.
Thank you, madam. Can I leave, madam? Hello.
Yes, sir. Thank you.
Can I leave, madam?
Yes, sir.
Okay, madam.
Moving further, our next presenter is Dia Binu George, and the title of the paper is Prediction of Rainfall in Himachal Pradesh Using Statistical and Machine Learning Models.
Good afternoon, ma'am. Am I audible?
Yes. Yeah.
Can I share my screen, ma'am?
Yes, please.
Good afternoon, everyone. So, my research paper is based on prediction of rainfall in Himachal Pradesh using statistical and machine learning models. So, starting with the introduction, the climate change disrupts hydrological patterns affecting rainfall variability, and rainfall, Himachal Pradesh particularly, is a place which is experiencing extreme rainfall, floods, and landslides. So, accurate prediction aids water management as well as agriculture and disaster planning. So, this study basically evaluates statistical and machine learning models for rainfall prediction. Starting with the motivation and the research gap. So, there are limited studies which incorporate the key climatic variables in rainfall forecasting. The nonlinear climatic interactions are often usually missed by the classical models used, and there is need for comparative measures, that is comparing linear versus nonlinear methods. And we also need studies which incorporates variables like temperature, relative humidity, wind speed, and monsoon effects. This is the motivation and the research gap which was identified for the paper. Now, moving on to the objectives of the study, we have developed a rainfall prediction model using Arimax and machine learning approaches. We have assessed influence of climate predictors on rainfall behavior. And the third one is to identify the model with highest predictive accuracy for Himachal Pradesh, and hence provide insights for which will help policymakers and disaster management units for taking appropriate measures. The related works which was used, there were many papers which I went through, and one of them is Himalayan rainfall variability, which extensively was studied in the papers which was done by Kumar and Thakral. ARIMA models which were used, but which are limited because ARIMA model assumes a linear relationship between the dependent and the independent variables. Machine learning models like random forest, SVR boosting, which showed improved accuracy. Importance of ensemble methods highlighted in several climatical studies. Now, the data set used in this research paper is a monthly rainfall data, which is taken from the years 1981 to 2015 from the OGD platform, Government of India, that is Government of India website. The climatic covariates were used from the NASA Power data, which was inbuilt in R. The variables used are temperature at 2-meter distance, relative humidity at 2-meter distance, and the wind speed at a distance of 10 meters. So the total data set has 420 observations spanning over a period of 35 years. We have divided the data into trained data and the testing data. Training data taken from the years 1981 to 2008, and testing data which is taken from the years 2009 to 2015. So the variables used in this study, the dependent variable being monthly rainfall in millimeters, independent variables being temperature, which is measured at a distance of 2 meters, the relative humidity at a distance of 2 meters, wind speed, and a monsoon dummy variable which is taken, which means it is taken as 1 for the months of June to September and 0 otherwise. So why we have chosen these predictors? We have given a predictor justification. Temperature influences evaporation and atmospheric instability. Relative humidity is a direct indicator of moisture necessary for rainfall. Then the third one being wind speed, which also governs the moisture transport and convergence. Monsoon indicator is chosen so as to capture the strong seasonal rainfall regime. And before taking these variables, we have also checked the correlation results, and the correlation results showed a strong positive correlation of these variables with the dependent variable rainfall. So the statistical and computational environment, all the analysis was performed in R. The key packages that we used were forecast, that is for Arimax modeling, XGBoost for the gradient boosting trees, then random forest for random forest regression, light GBM for the light GBM model, and E1071 for SVR modeling. So the modeling approaches, the first one, Arimax model. Now why we used Arimax? It captures temporal and linear climatic effects. Now the second one was the XGBoost model. That is a sequential boosted trees capturing nonlinear interactions. You can see rainfall strongly has nonlinear patterns or interactions. So XGBoost ML models were more helpful in capturing such nonlinear patterns. So the third one was the random forest model. It is an ensemble of bootstrap decision trees. The fourth one being light GBM, which is a leaf bias boosting for efficient training. And the last one being SVR model, it captures nonlinear boundaries in predictor space. So the model evaluation criterion, how we assess the different models. The first one being RMSE. The RMSE penalizes large errors. It is good for extreme rainfall evaluation. The second one was the mean absolute error, MAE. It measures the average prediction errors. R square, proportion of rainfall variance explained by the model. And the best model was chosen based on the minimum RMSE, minimum MAE, and highest R square. So based on the performance summary, we got the XGBoost being the best model which performed, having the least RMSE, MAE, and the highest R square. The tree-based ensemble models outperformed the linear and kernel-based models. Arimax model performed moderately well, but it struggled with extreme values of rainfall. SVR had difficulty capturing high rainfall variability patterns. So these were the results that we got for the different models, starting with the XGBoost model having the least RMSE and MAE and highest R square value of 0.7, which means that the variables temperature, humidity, and wind speed were good predictors explaining maximum variation in rainfall. This was followed by random forest having the next least RMSE and R square values, followed by Arimax, light GBM, and SVR performing the least. The discussion of the findings, we found out that XGBoost handled the nonlinear and seasonal interactions effectively. The relative humidity at 2 meters emerged as a top predictor, indicating that moisture dominance is an important predictor for rainfall. Arimax is a good model, but then it is limited by its linear assumptions. So the tree-based ensemble captured extreme rainfall peaks better compared to the linear models like Arimax. The limitations in the future scope, the data is limited to only one state, that is Himachal Pradesh. So it limits spatial generalization. Potential measurement errors in observed rainfall data can also be one of the limitations. The third one, since the data is not a very huge data set, there are chances for overfitting in the case of light GBM. Now, future work can expand this to district level spatial modeling And also we can incorporate hybrid and statistical models. A combination of these ML and statistical model can be used for better results. There's a concluding part. XGBoost model was identified as the most accurate model for rainfall prediction, with 70% variance in rainfall using climatic predictors were explained. Machine learning greatly enhances predictive accuracy, and this is useful for hydrological planning and disaster preparedness. Thank you.
It was nice presentation, ma'am.
Thank you, ma'am.
Ma'am, I have one question that
Yes.
can extreme rainfall like cloudburst or flash floods be predicted by your work?
Sorry, ma'am, can I have the question again?
Like, can extreme rainfalls like cloudburst and flash floods can be predicted by your work?
Yes, ma'am. The XGBoost model can be used for predicting cloudburst events. So it is, since it's a machine learning model, it has good performance metrics, and usually it can, based on the research papers that I've read, XGBoost model has outperformed all the other models compared to the classical models used, and it can be used in cases of extreme weather events also.
Okay, okay, good. Thank you.
Yes.
Thank you, ma'am. Moving
Thank you.
further, we have our next presenter, Yashoda MB, and the title of the paper is Reimaging Career Counseling in India, Large Language Models as Catalysts for Accessible Guidance.
Hello, am I audible?
Yes, sir, you are.
Okay, I will share my slide. Good afternoon, everyone. My name is Anthony Pinto Robinson, and I, on behalf of my team, will present this paper titled Reimagining Career Counseling in India, Large Language Model as Catalyst for Accessible Guidance. I will start with the introduction. Career counseling plays a critical role in helping students making informed decisions about their futures. However, 93% of students are uh, aware of only few career options such as engineering, medicine, and law, despite a few hundreds of valuable career paths available today. This problem is particularly severe in rural and economical unreserved regions, where access to trained career counselors is limited. As a result, many students choose careers based on social pressure or limited information rather than actual skills, interest, and aspiration. This often leads to skill career mismatch and long term dissatisfaction. In this work, we explore such AI-based approach and can be used to improve career counseling accessible and effectiveness, particularly for students who lack access to traditional guidance systems. Our motivation. The motivation behind this comes from the limitations of existing career guidance system. Today, most career counseling depends on human counselors, making it difficult to scale and often inaccessible to students in rural and economical disadvantaged regions. And ever since the COVID pandemic, we have gone into a remote era where virtualization through internet had made possible to many such events. For example, work from home. And this gave us an idea of AI-based career guidance system to remote areas and rural places. At the same time, our latest advances in LLM models have shown strong potential in understanding unstructured data, reasoning across multiple factors, and providing personalized recommendation. This creates an opportunity to develop a scalable, intelligent, and highly intelligent career recommendation systems. And our motivation is to leverage this AI capability to support students with personalized data-driven career recommendation while reducing dependence on limited human counseling sources. In our literature survey, we reviewed existing approaches on AI-based career counseling to understand the current capacity and capabilities and limitations. Several studies have proposed AI frameworks that assess students in choosing careers based on aptitude, skill, and goals, showing the data-driven guidance can improve decision. Other focuses on chatbot-based career counseling, which improves accessibility by providing 24/7 guidance, but these systems often lack deep personalization. Overall, the literature survey, while existing system addresses aspects such as accessibility, skill, and language support, there is a gap in integrating contextual understanding, similarity based on matching, and mentor support in a single scalable framework. Our work aims to bridge this gap. This slide represents the system architecture of of our paper. This slide shows from there are two pipelines, the student pipeline and the mentor pipeline. From the student's point of view, the student first submits essential information such as academic records, interests, and activities into the system. This data is stored and processed by the Career Connect platform. The platform we have created using the LLM augmented reality generation, RAG, and for prompt tuned it. The large language model integrated with retrieval augmented generation analyzes the inputs and suggests the top careers options using cosine similarity based matching. After receiving the recommendation, the student selects a preferred career and aptitude test is conducted to evaluate these skills and refine the recommendation. Based on the selected career, the platform also integrates learning resources such as YouTube Udemy courses to support upskilling. In parallel, the mentor pipeline allows mentors to submit their professional profile into the system. Using cosine similarity, the students connect with the suitable mentors through Student Connect module. This enables mentor counseling, combining AI-driven recommendation with human guidance. Overall, the architecture integrates AI-based career recommendation, aptitude validation, and learning support, and mentor interaction in a single platform. For this study, we use synthetic data set to simulate a real-world student and mentor profile. The primary reason for using synthetic dataset was to address privacy and ethical concern. As real students' career data is highly sensitive and difficult to obtain at large scale. The dataset was designed to support the development and testing of Validation Career Connect platform by simulating realistic career counseling scenarios. AI-based generation techniques were used to create diverse student and mentor profile representation. Different different educational backgrounds, interest, and aspiration. This combination of AI generation and manual verification improve the reliability of the dataset. The dataset serves as the backbone of the cosine similarity based matchmaking algorithm. While while the LLM Llama 3 processes student profile to generate personal recommendation careers. This result shows the Career Connect AI model performs effectively in predictive suitable careers matches. By using careers by using cosine similarity, the system aligns students' interest and profile with relevant career paths and method expertise. This is the pre-processing of the data of the model. Our system follows the guide. Our system follows guidelines and principles methods to ensure responsible and effective career guidance. User privacy and data security are treated as top priority, analyzing data handling and control access. We follow ethical AI principles by aiming to reduce and ensure fairness across different student backgrounds. The system is designed as a human in the top loop, where AI supports decision making rather than replacing human career counselors. The result and analysis. The result shows the Career Connect AI model performs effectively in predicting suitable career matches.
Sorry to
By-
interrupt, sir. This is a gentle reminder. You have 1 minute to conclude your presentation.
Okay, ma'am. By using cosine similarity, the system aligns students' interests and profiles with relevant paths and career experts. We also observe that the mental matching accuracy improve when both similarity and personality capable, uh, capabilities are considered, rather than relying on academic performance. Overall, this emphasis emphasizes the importance of feature selection, algorithm refinement, and feedback interaction to further improve career guidance accuracy. Here we have the graphical representation of the distribution of cosine similarity and the working of the data set. And so further, we can see the precision and versus the cosine similarity threshold and the confusion matrix. In conclusion, Career Connect provides an AI-based career counseling, career guidance to students in rural and undeserved areas, and personalized guidance for students in different backgrounds, not only in their academic records, but also the interest, skills, and other aspects, thereby increasing their future in a satisfied career in their future goals, and thereby assuring them a life of learning and earning as well. Thank you.
Sir, you presented very well. So, by this career counseling in India, by using LLMs, uh, according to you, sir, what safeguards are necessary to minimize like misinformation or biasness?
Ma'am, can you come again?
Yes, what safeguards by your work are necessary to minimize misinformation and biasness? Is there any safeguard we need to implement in your work?
Ma'am, what we actually do in this particular scenario, as you told, we implemented prompt tuning. This prompt tuning helps us to make a proper and informed career guidance, career recommendation to the students as required. And moreover, in while using prompt tuning, we also implement RAG, which also enhances and all railguards in
Okay.
particular, making sure the LLM gives an informed decision to the students in their guidance in their path towards a proper career.
Okay. And is it possible, can we align your work to NEP 2020?
Yes, ma'am.
Okay. Thank you.
Yes, ma'am. We can do this with the help of RAG.
Thank you, sir. Moving forward, our next presenter is Smita Vimpati, and the title of their paper is Securing Smart Cities, a Cybersecurity Framework for Digital Twin Creation Using Soft Computing Technologies to Mitigate Malicious Attacks.
Good afternoon, everyone. I'm Smita. I'll be presenting this paper today. The paper is about smart cities, a cybersecurity framework, and creating a digital twin to mitigate the malicious attacks. So the context of the problem is cybersecurity in smart cities. As we know, most of our cities are smart cities nowadays, and the security is not that great nowadays because we have everything online, starting from our phones to the physical assets we have. Most of these are called IoTs, and we'll talk about digital twins more in the upcoming session. But the context of the problem today is the cybersecurity in smart cities and emerging threats on how we can mitigate these cybersecurity in IoT devices. So the rapid development of smart cities uses like IoT devices and digital twins as well in the urban management and resource allocation. So how we can use our ML models and AI detective models to mitigate this cybersecurity threat and reduce the cyber attacks on these physical assets that we have. So there are some models that were suggested by Smith and Kumar in 2021, and there are some that were proposed by other authors, but they haven't created anything with the digital twin. All these proposed models are on AI and ML techniques and data analysis. What we are trying to do today is create a digital twin. Digital twin is a physical model that we train to mitigate to give some data to that and train that to mitigate these attacks. What are the objectives of our paper today is to mitigate, like I said, to mitigate the cybersecurity like framework using AI and ML techniques, and using the deep learning techniques will take the data and model the digital twin. Motivation is again like the increasing vulnerabilities in our society today. Since we are using many IoT devices, apart like from morning till evening, like when we are traveling in car everywhere, we are using IoT devices, and the threats is a lot with the critical infrastructure. We are using the IoT device in transportation, healthcare, and the potential consequences are like losing the critical data, service outages because of these cyber security attacks. So we're trying to mitigate that with this research. Try as much as possible to give a secure environment to people. The scope is again creating focus on digital twins and IoT environments. Most of the models that were trained so far is with cyber security and IoT devices, but digital twin is the one that we want to focus on this research to train a digital twin, create a physical model, and train the digital twin to mitigate any attacks. Like I said, we have IoT usage in everywhere, from smart homes to energy engagement, wearables, agriculture, smart manufacturing, transportation, and cars and healthcare. So this is how our life is inclined with IoT. We are connected with IoT everywhere from our homes to the cities. So the role of digital twin smart cities is how it will help to create a smart city. It will the predictive analysis that it can do to mitigate any not only the cyber attack, but to for the free traffic flow, for environmental air pollution, everything it can monitor. Our process is to create a cyber security one, but we can expand our research to traffic analysis, energy usage, live feed of urban systems, city resilience, and everything. So this is how our current digital twin usage is in smart cities right now. There are many companies that have adopted this digital twin in manufacturing, healthcare, transportation, automation, and everywhere. These are one of the examples that I have provided here, which is in Singapore that they have adopted this. The model proposed is we'll take the big data. The data right now comes from Kaggle and local sources that we have identified for the government from the government. Mostly the data we have obtained right now is from Hyderabad. The main challenge here is obtaining the data from every city and throughout the connecting every city. For now, we are focusing only the database from Hyderabad to create a small digital twin here. So this is the model we have proposed, like the big data, and we'll create an AML model to train that, create a digital twin using IoT. So these are some of the mechanisms that have been proposed in analysis of data. We have taken a few from here to analyze the data. We haven't created anything that is our own, that is our future work, that we wanted to add some more algorithms to analyze the data we have. So this is the research that have been done so far. The attacks that were, these are the references I have given here from some of the authors from 2019. So from the algorithms that they have proposed, this is how they were able to mitigate train the AML models and reduce the cyber threat. So the models they have taken is like the traditional IDS, AML, A and ML based model and site-of-the-art model. And these are the predictions they have provided so far from 2020 paper references and 2015 paper references that we have got so far. These are the data is whatever they have provided is again local data they have taken, like how we are trying to do right now. Our future model would be something like from for all over India. And this is a cyber attack type, like cyber threat detection, how they were able to mitigate the cyber threat from the detection and how they have applied the algorithms to mitigate the cyber threat. There are like few types of digital twin modeling today. One is like the data driven. The second one is rule estimator models, where they have both physical and data driven models together. This is how they'll have their similarity model, they'll have a survival and degradation model. The other one is a model training physical based. So they have both data and the physical based model that they create. This is one of the example I have taken. This is not related to cybersecurity, but how the training physical based digital twin works. That's what I want to show here. So the key experiment results are like, most of the digital twins have been used in this and they have achieved a lot of progress in that, but they haven't done anything with the cyber security in digital twin. That is what we're trying to achieve today. So that's the summary of our contributors, like how we can adopt a digital twin to reduce the cyber security in smart cities.
It was nice presentation, ma'am.
Thank you.
Ma'am, I have one question that in your cyber threat and detection mitigation, so have you faced any scalability issue during your work?
We have, because the data we have is really small, like we have taken only one city, that too. We have like limited data here because we have to get the data from IoT devices like security cameras and phones and maybe, even Google Maps. So we do have some scalable issues right now, but we are trying to
Yes.
mitigate those. Yeah.
Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you.
Moving further, we have our next presenter, Vaishnavi Vedivellu. The title of their paper is Smart Cities and Green Innovation, a literature review of sustainable development strategies.
Ma'am, am I audible?
Yes, ma'am, you are.
Is it my screen is visible, ma'am? Ma'am, my
Yes, ma'am,
screen
it
is
is
visible,
visible.
ma'am?
Yes, yes.
Yeah.
Please
Shall I
start.
start? Thank you.
Yes, ma'am.
Good
Please
afternoon.
start.
This is Dr. Vaishnavi from Congo Engineering College from the Department of Management Studies, and I'm happy to present here the work which we have done it on the literature review of the smart cities and the green innovation. Because nowadays everyone is moving towards the development of the sustainable development goals, and the people have been going everything along with the environment and giving much impact on it, and also they were using all the tools and things which be more useful in the green aspects by reducing the wastages and also the errors and the emissions. And the excess usage of the electrical and other aspects is being reduced with the by when you adding with the developed tools like IoT, AI, along with the green, it be more efficient and energy saving aspects. So in which we have taken about the green cities and the smart innovations. In India, many cities have been moving towards the smartest aspects in all the aspects of reducing the emissions and also in the transportations and all other aspects in infrastructure developments and connecting all the areas in business and agriculture, all the aspects. So we took it as one aspect to explore how it has been done it over and also how it has been much influenced in the urbanization and the other aspects, how they have looked into how we can minimize the emissions and energy efficiency and sustainable development throughout our like because the scarcity of the natural is very minimal. So what we are going to provide it for the next generation is the biggest question mark. And here we used and we have collected the data based on the smart cities, which includes IoT, AI, and big data related tools, and along with that, how it has been studied over and how it has been contributed over. And we have selected the data from the year of 2021 to 25 because we have taken only last 6 years of data. And also we have selected and limited to only the empirical research related articles, and also we eliminated literature review articles there. And also we have uh, uh, constrained into the among the um, articles in the area of from the publishers like Emerald, Elsevier, and Springer, Taylor, and Francis. And also we have limited to certain aspects, and we have taken only the highly empirical related articles, and also we have looked only with the peer review journals, and also we have selected the articles based on the themes like technology, infrastructure, government policies, sustainability, and other things. And we come out with the various thematic classifications, in which first we have looked into the year-wise publications from the 2021 to 25, where in 2023 there are peak publications was being higher during that period, and also during that period only 17 articles has been published around 50 articles. So that period has been mentioned that much research has been happened over it. And also we have checked with the country-wise distributions also. In country-wise distributions, the Brazil is the one has the highest publications from the 14 articles, and also the China and the other countries also has been more contributors. And also we have looked on the classification or the categorization has been done it on the publisher prospectus. Elsevier has been used much related publications related to the smart cities and green related aspects, in which the sustainable city and society journals, ecological indicators, journal of cleaner production, journal of urban management, and journal of innovation and knowledge
and Sustainable Energy Technologies and Assessments. These are the journals where the more articles have been published on that particular period. And also we have looked on the authors who have been contributed more on it. There are many authors have been contributed more, and in which cases Sinha, Yang, Ted, Zhang are being much contributions on the smart city related empirical research oriented, and also they have written various literature review articles on this areas. And also we have tried to classify what are the factors are being affecting or it is being contributing when you look into the study related to empirical aspects. So it is also being classified like policy, governance, privacy, security aspects, and also technology, infrastructure developments, and the economical aspects also being looked over it. Along with that, they have looked more on the economic growth and also the data management perspectives. After, with the keywords, how it has been classified over furtherly, it is also being looked into. Because this literature review article will give you some complete understanding how so far the research has been carried out. So that's why we have classified the uh, result in these categories. In keywords perspective, six common connected, interconnected themes have been classified. First, it looks on the smart cities and urban sustainability. Second, perspectives on the green technologies and innovations for the eco-innovation perspectives, and how the energy and environmental related aspects have been contributing for the renewable energies and smart grids and the climate related aspects. And transport mobilities are being done it over, and along with the data management related to the IoTs as well as AIs, how it has been contributing over. And finally looked into the aspects of governance, society related aspects. And finally, we have identified what are the futuristic directions which will help you in the ongoing aspects on the smart city related uh, projects. Like it will help us to extend our research on the complete development and the sustainable development goals, and also much focusing on the policy recommendations and the implementation plans, and along with the green IoT, which will be more useful on the aspects which helps us to move towards on reducing the carbon footprint and also the improving on the energy efficiency. And also the further ideology we got it from the Olivria related to the urban blue and the green infrastructure related aspects, where local food developments and food and all these aspects also being considered over. And also AI and deep learning, blockchain related transportation and management of resources will be more useful. So the challenges is related still, the all the developments which are happening in the information technologies related to it, the same challenges is also been applicable in the smart cities also. The privacy threats and infrastructure cost and the digitalization related aspects, and we won't have a much private policies and other aspects. So these are the could be the challenges. Still more we were facing further developments of the happening over. With that, I'll conclude it that smart cities and green innovations are more required for the sustainable developments, and also the cost and the security related and governance related aspects are the still limitations which we have overcome it with the futuristic directions. By which I'll conclude, and I'll thank the conference team members by giving us an opportunity to present on this area, because this is completely purely a literature review article from management's perspectives. We were only able to do it, but we couldn't do an empirical research. Thank you.
It was nice presentation, ma'am.
Thank you,
Uh,
ma'am.
Ma'am, according to you, what barriers or enablers affect the implementation of this green innovation in smart cities?
And first, it is about the threat which we always have it on the privacy related aspects, ma'am. And the people
Hmm.
are not able to go with the transparent related certain informations and data. So that is the one thing the people are being hesitating to go with all these aspects. So if you able to give that privacy related issues, if you will be able to minimal and if we have a high security related, so that could be the first priority, and the regulation should be designed in such a way that is the one thing the government side we were very lagging, and the perspectives have been changing from the different industries and different scenarios. So we couldn't go with some certain policies or the guidelines related to it. If we can overcome these two things, then it has been implementation perspective is somewhat it has been achievable.
Okay, okay. Thank you, ma'am.
Thank you. Thank you.
Thank you. Now moving further, we have our presenter, Anvita Ji, and the title of the paper is Why Consumers Resist Green Logistics, a Structural Analysis of Barriers in Last Mile Delivery.
Good afternoon, ma'am. Ma'am, am I audible?
Yes.
So good afternoon, everyone. So I'll be presenting our research study on why consumers resist green logistics as structural analysis of barriers in last mile delivery. So let me begin by defining the terms green logistics and last mile delivery. So green logistics is actually it refers to the minimizing environmental impact in supply chain activities like transportation, warehouse, distribution, and also by it reduces this supply chain activities by by reduction of waste and energy emissions. So, and last mile delivery is actually the final step in logistics, which refers to transportation of goods from warehouse to the customer doorstep. Now coming to the context, so in recent years, e-commerce has grown rapidly, and due to this, last mile delivery has been increasing rapidly, and also it led to environmental problems like emissions and congestion, and also air pollutions. And although the green delivery options exist, the consumer adoption of these green delivery options remain extremely low, and consumers still prioritize price, speed, and convenience over the green delivery options. And also the existing studies focus more only on the firms and not on the consumer resistance, and like they focus only on the enabler side like technology or regulation, but they do not focus on the consumer behavior patterns. And also this consumer resistance is actually habit driven and also emotional. So consumer resistance is actually very interdependent and complex. It is actually motivational, informational, and emotional. So our study addresses this gap by 11 key barriers to green delivery using the ISM MICMAC analysis. Now coming to the motivation. So our achieving sustainability is impossible without consumer participation to choose the green delivery. And however, existing work only emphasizes on the technology and regulation and not on the behavioral resistance. So and also there is no particular ISM MICMAC analysis like hierarchical analysis, especially in the context of Indian market. So we have framed three research questions like what behavioral, informational, and operational barriers exist, how do these barriers interact structurally, and how can logistic providers reduce resistance. Now coming to the theoretical background. So our study integrates three behavioral patterns to study the last mile delivery. First is the theory of planned behavior. So it explains resistance through weak attitudes, lack of social pressure, and low perceived control. And also this links to barriers like low ecological consciousness, weak social pressure, and cost and convenience constraints. And second is the value belief norm theory, which suggests that sustainable behavior requires moral activation And this breaks down when consumers lack credible information like poor certification awareness and low carbon transparency. And coming to the third framework, which is BIS or BAS framework, it explains emotional avoidance. Like consumers avoid behaviors which are perceived as high risk and high effort or inconvenient. So this actually explains the emotional resistance through constraints like price sensitivity, convenience rigidity, and also negative past experiences. So together, these theories show that resistance is attitudinal inertia, moral disengagement, and effective avoidance. So this integrated lens forms the foundation for our ISM MICMAC modeling of these barriers. Now coming to the first set of barriers, so they relate to motivation and information. So many consumers show low ecological consciousness, meaning they don't associate their delivery choices with the environmental impact. And now second barrier is the low awareness of green certifications. So companies do not provide clear eco labels, and also some companies actually follow greenwashing, like it is a deceptive marketing tactics, promoting their products in such a way that they are more eco-friendly than they actually are. So which leads to distrust and confusion among the consumers. And coming to the barrier three, which is price sensitivity, it especially in developing markets where price elasticity is high, consumers perceive sustainability charge as premium charge. So they feel that this charge is actually unfair or unaffordable. And also coming to the barrier four, which is rigid convenience expectations. So the consumers are habituated to fast delivery, flexible and also on-demand delivery. So sustainable or green delivery is often seen as slow or inconvenient. And also coming to the barrier five, a low trust in digital tracking. So consumers have doubts about the accuracy of carbon tracking, and also there is lack of verification mechanisms that reduces the claims of these green claims. Now coming to the second set of barriers, which are related to operation and experience driven. So barrier six, it is perceived poor reliability. So there is fear of delays and inconsistent services, especially related to these green deliveries. So consumers associate green delivery with operational uncertainty. Now coming to the barrier seven, which is perceived unfair green pricing. So consumers feel they are being penalized or charged for choosing sustainable options. Like there are price differences between standard delivery and green delivery, which are often seen as punishment rather than contribution. And also barrier 8, which is lack of social norm pressure. So there is no visible peer endorsement of green delivery, and sustainability is often seen as low status or it does not have any recognition. And also coming to the barrier 9, which is low transparency of carbon impact. So consumers don't see the tangible emission reduction from their choices, so they naturally think so the carbon matrix also fails to motivate their behavioral changes. Now coming to the barrier 10, which is unwillingness to pay. There is a strong gap that exists between environmental intention and also actual payment. So consumers see no immediate personal benefit from paying the extra amount for these green delivery. Now coming to the barrier 11, which is negative past experiences. One poor experience leads to long-term avoidance of green options, and also negative emotions outweigh these future environmental considerations. And now coming to the methodology, so we frame four-step methodology. The first step is a comprehensive literature review. So we identified 11 key barriers, which are labeled as barrier 1 to 11. And then second, these barriers were validated by a panel of 10 experts from logistics, sustainability, and academia. And in third step, we applied ISM modeling to build a hierarchy of barriers and also MICMAC analysis to classify them as driver, linkage, or dependent barriers. And coming to the step four, we triangulated the findings using a structured survey of 159 respondents in India, ensuring both structural and also the empirical validity. Now coming to the key implications. So theoretically, our study extends the theory of plant behavior by explaining information and also the intention gap. And also it extends value belief norm theory by showing how eco-label opacity blocks moral activation. And also it integrates BIS or BAS framework, explaining the emotional resistance of the consumers. And practically, firms should be able to make the green delivery a default option at checkout. And also they need to provide clear carbon impact dashboards, unified certification systems, and also reliable green delivery standards that can significantly reduce the resistance. Now, using social proof such as badges or visibility cues, they can help normalize these green choices, while subsidies and efficiency improvements can also reduce the price premiums. Now, coming to the conclusion. So, to conclude, consumer resistance to green delivery is extremely layered, complex, and multidimensional. So, our root barriers are low ecological consciousness and poor certification awareness, which leads to mid-level constraints like price sensitivity, fairness, and also convenience expectations. And this ultimately results in dependent outcomes such as unwillingness to pay and negative experiences. So, the solutions must target motivation, information credibility, and also operational trust simultaneously. Now, strengthening these green delivery adoption is essential for accelerating low carbon logistic goals. So these are the references which we taken which is based on our study. Thank you.
Yes, Anvitha, you presented very well.
Thank you.
So, I have question like, how do technological solutions like electrical vehicle or parcel lockers, or we can say route optimizer, affect the consumer perception?
Like ma'am, they can actually help in minimizing the environmental impact. So if the consumers must be made aware of these uh, delivery choices, like the companies must provide clear certifications and labels, like what they are practicing and what they are implementing in these delivery choices. And also they need to be uh, charging the prices accordingly. So they should not be charging extra amount. They should be only be charging according to the products they are delivering to the consumers, so that this resistance can be reduced significantly.
Okay, okay, thank you.
Thank you.
Thank you. I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9th versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I also thank our session chair, Dr. Kamlesh Ahuja, for chairing this session. Thank you, ma'am.
Thank you, ma'am, for inviting me. And I would like to thank all the authors for sharing their valuable research contributions.
Now I thank you again, ma'am. Uh, this is a token of appreciation of the chair on behalf of Team ICTCS 2025 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Now, I kindly request all of you to switch on the camera for a quick snapshot of this virtual conference. Please give me a minute. Thank you, everyone.